Alright, so in this problem, I have x minus 4 to the power of 4 is equal to x to the power of 4. So to solve this, I'm going to first start by subtracting x to the power of 4 on both sides. So these two cancel out, and now I'll have x minus 4 to the power of 4 minus x to the power of 4 is equal to 0. Now, I can rewrite x minus 4 to the power of 4 as x minus 4 squared to the power of 2. And I can rewrite x to the power of 4 as x squared to the power of 2. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. In this case, a is equal to x minus 4 squared, and b is equal to x to the power of 2. So now I have x minus 4 squared plus x squared times x minus 4 squared minus x squared. This is equal to 0. Now, x minus 4 squared, if I expand that, I get x squared minus 8x plus 16. Now I have this plus x squared times x squared minus 8x plus 16 minus x squared is equal to 0. Now for my left-hand side, these two cancel out, and for my right-hand side, these two add up. So I get 2x squared minus 8x plus 16 times negative 8x plus 16 is equal to 0. So now this gives me two equations. I have 2x squared minus 8x plus 16 is equal to 0, and I have negative 8x plus 16 is equal to 0. So for negative 8x plus 16 equals 0, I simply add 8x on both sides. And I get 16 is equal to 8x, meaning x is equal to 2. So this is one solution of x. Now for 2x squared minus 8x plus 16, you can first start by factoring out 2. So I get x squared minus 4x plus 8, which is equal to 0. Now I can just take off this 2 by dividing both sides by 2. So now I have x squared minus 4x plus 8 is equal to 0. So to solve this, I'm going to use the quadratic formula. And I'm actually not going to waste your guys' time by actually solving this, because that's going to take a while. But you do end up getting x is equal to 2 plus or minus 2i. So if you use the quadratic formula, this is the result that you should get. So these are my three solutions to this problem. My first solution is x equals 2. My second solution is x equals 2 plus 2i. And my third solution is x equals 2 minus 2i. So these two solutions are imaginary, and I have one real solution. Alright, so in this problem, I have 9 to the power of x is equal to 18. So I want to find the value of x here. So for my solution, I first start with 9 to the power of x is equal to 18. Now to solve this, I'm actually going to take the log on both sides. So now I have log 9 to the power of x is equal to log 18. Now if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times log a. In this case, I have log 9 to the power of x, and I can move x to the front. So that's going to equal x times log 9, which is equal to log 18. Now I'm going to go ahead and divide both sides by log 9. These two cancel out, and I have x is equal to log 18 over log 9. Now log 18, that's the same thing as log 9 times 2. And if I have something in the form log a times b, this is equal to log a plus log b. So log 9 times 2, that's going to equal log 9 plus log 2. Now I have this over log 9. Now this is the same thing as log 9 over log 9 plus log 2 over log 9. Log 9 over log 9, that's simply equal to 1. So I have 1 plus log 2 over log 9, I can rewrite as log 3 squared. And remember, if I have something in the form log a to the power b, I can simply move b to the front. So in this case, log 3 squared, I can move 2 to the front. So now I'm going to have 1 plus log 2 over 2 times log 3. Now, log 2, that's equal to 0.301. And 2 times log 3, that's 2 times 0.4771, which is equal to 0.9542. And 0.301 divided by 0.9542 is 0.3154. So if I add these two, I get x equals 1.3154. So this is my answer. Alright, so in this problem, I have 4 to the power of x minus 2 to the power of x is equal to 1. So to solve this, I'm going to first go ahead and rewrite 4 to the power of x as 2 squared to the power of x, because 4 is 2 squared, minus 2 to the power of x is equal to 1. Now, I can actually switch the places of these two exponents, so now I have 2 to the power of x to the power of 2, minus 2 to the power of x is equal to 1. Now, I'm going to let y equal to 2 to the power of x. So now I have y squared minus y is equal to 1. Now all I have to do is subtract 1 on both sides, and I get y squared minus y minus 1 is equal to 0. So now I have a quadratic equation to solve. Now, my quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. So in this case, a is equal to 1, b is equal to negative 1, and c is equal to negative 1. So I have y equals negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times 1. That's the same thing as 1 plus or minus the square root of 1 plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So now remember how we set y equal to 2 to the power of x. So if y equals 1 plus or minus the square root of 5 over 2, then I have 2 to the power of x is equal to 1 plus or minus the square root of 5 over 2. So my two equations are 2 to the power of x equals 1 plus the square root of 5 over 2, and 2 to the power of x is equal to 1 minus the square root of 5 over 2. So first off, 2 to the power of x equals 1 minus the square root of 5 over 2. 1 minus the square root of 5 is going to be a negative number, and 2 to the power of a positive number to the power of an exponent can't equal a negative number. So this is wrong. So all I'm left with is 2 to the power of x equals 1 plus the square root of 5 over 2. So to solve this, I'm going to take the log on both sides. Now I can move x to the front, so now I have x times log 2 is equal to log 1 plus the square root of 5 over 2. Now if I divide both sides by log 2, I get x is equal to log 1 plus the square root of 5 over 2 over log 2. So this is my answer.